We're going to talk about some more advanced factoring in this next section, so I want to review just standard factoring first. Remember, how do you factor this trinomial of x squared plus 6x plus 8? Well, the factor means to put it into its two groups. And don't forget, the x squared gets broken up here. The 8 gets broken up here, such that when we multiply that term and add them up, we should get the 6x. So to break an x squared up, the only way to do it is x and x. Factors of 8 are either 8 and 1 or 4 and 2. They have to multiply to a positive 8, so what if we try plus 4 plus 2? When we multiply that, 4 times x is 4x. X times 2 is 2x. If you add this and this together, you get the 6x, so that is considered factored. Number 2, be careful. There's an x squared and a 9. Where's the x? Remember on this one, there's a 0x if you want to see it there. Factoring works the same way. I'm going to do two groups so that the 4x squared goes here, the negative 9 goes here, such that when I multiply these two together, they'll add to 0. Now you have to just kind of play with it, but a good trick is if the two numbers they give you, like the 4 and the 9, if they're nice, become nice perfect square roots, odds are the combination for the 4 is not the 4 and the 1, but the 2 and the 2. The 9 is probably not 9 and 1, but 3 and 3. So let's first break up the 4x squared. It definitely goes x and x. Each one gets one x. So it's either 4 and 1 or 2 and 2. I'm going to try 2 and 2. Now for the negative 9, two numbers have to multiply to negative 9. It might be negative 9 and 1. Could be negative 3 and 3. If I try negative 3 plus 3 and I check it, negative 3 times 2x, positive 3 times 2x. Those two add to 0, so this is considered to be fully factored. So in section 6.6, the first objective is we're going to factor polynomials. So these are higher ones. They're x cubes and x to the fourth, and I'm going to show you some tricks. So this works just like what we did previously on the other slide, but we first want to factor out anything they have in common. It's called a greatest common factor. If you look at these two terms, is there a number or some x's you can yank out? And I'm first going to notice I can pull a 3 out of both. So I'm going to pull a 3 out. So I'd be left with x cubed, because 3 divided by 3 is 1. 27 divided by 3 is 9. But I still have that x. So anything else we can pull out? Here I have 3 x's. Here I have 1 x. I can actually pull 1 x out of both. So I'm going to show that as being pulled out. So 3, I'm going to pull the x out and show that I kept it. Notice there's only going to be 2 x's left here, and this other x is going to be gone. So this is actually partially factored. What you want to do is determine if you're done factoring. Always go to the factors that still have a squared or a cubed and think about if you can break it down into two smaller groups like we did earlier in other chapters. This one, the 3x stays, but x squared minus 9 can be factored. Notice the middle term is 0x for this. So what I do again, the x squared goes here. You can only break that up into x and x. The negative 9 is going to go here, such that when I check these two terms, it'll add to nothing in the middle. Two numbers that multiply to get negative 9, such that they add to 0, would be would 9 and negative 1 work, negative 9 and 1, or negative 3 and 3. In this case, if we do negative 3 times a positive 3, that is the negative 9 right here. And this is negative 3x, positive 3x, which adds to no middle term. This right here is the fully factored answer. Now this one here is a little bit trickier. Again, take a look at it. Is there anything you can pull out of both terms to make it look nicer? Can we pull out a multiple of 4 from 16 and 81? It does come out of 16, but unfortunately not out of 81. Can we pull x's out of both terms? Well, there's 4 x's here but there's no x's here, so you can't pull any x's out. The only thing you can do here is factor this into two groups. And let me show you, this gets a little tricky. I need to be able to pull apart 16x to the fourth. Now, x to the fourth needs to be broken into two groups here, equally broken up. The only way to break up 4x's equally is to give each of them 2. So this would be x squared, and this would be x squared. It works like that every time. Now you have to break the 16 up. And that can either be 16 times 1, 8 times 2, or 4 times 4. One of those three combinations is the correct one, and it's just guess and check. Now here's the deal. When I see 16 and 81, I know they both become nice perfect square roots. If I take a square root of 16 is 4, square root of 81 is 9. So my gut is telling me it's the 4-4 combo. So I'm going to try 4 and 4. Notice there is no middle term on here, so it means when I multiply this and add it up, it'll zero out. My only other option is I have to break negative 81 up into two numbers and put those here. So 81 is either going to be 81 and 1, 9 and 9 might work. What if we try plus 9 times negative 9? So I'm going to do plus 9 minus 9. Now if you notice this, 9 times 4x squared is 36x squared. 4 times x squared times negative 9 is negative 36x squared. When you add these two terms together, you get 0, so it actually works. Now before you circle this as your final answer, you need to check and see if you can either factor it further. I will tell you, one of these two groups can be factored into two smaller groups of 2. It's this one right here. So I'm going to put my original answer, or not the original, but this first part, 4x squared plus 9, is not factorable any further. But this guy is. So I'm going to factor it into two groups. I have to put 4x squared here. So I'm going to break the x's up. Again, it's either 4 and 1 or 2 and 2. I'm going to try 2 and 2. The negative 9 has to go here and here. So it's either negative 9 and 1 or negative 3 and 3. I'm going to try negative 3 plus 3. Notice there's nothing in the middle. There's no middle term, so it needs to zero out. Negative 3 times 2 is negative 6x. 2x times 3 is positive 6x. Those add to 0. Okay. Now, I will tell you, though, if you try to factor this other one, you're going to notice it actually won't work. So let me just kind of show it to you really quickly. If you were to try, 2x and 2x, and then to get positive 9 would be like plus 3 plus 3. That would give you a middle term of 6x. Even if you played around with it, it wouldn't work. So our final answer for factoring is these three groups. Let's look at another one. Again, your strategy is always to see what you can yank out of everything. If you look at these three, you can yank a common number out, a common multiple. You can take a 6 out. Also, here's 6 x's, there's 4 x's, and there's 2 x's. You have to be able to pull the same amount out of each one. So if you look at it this way, there's the 6, there's 4, and here's 2. You're going to notice you can only take 2 out of there, so that's all you can take out of everything. So I'm going to take out an x squared and rewrite it. 6 divided by 6 is 1. And x squared out of 6 x's would be x to the fourth. Negative 6 divided by 6 is negative 1. I'm going to pull out 2 x's. Negative 12 divided by 6 is negative 2. And I actually pull out both of those x's are gone. Now I'm going to see if I can factor what's on the inside here. I'm going to keep 6x squared. And here's what I do. I break up 1x to the fourth. Again, x to the fourth, each group goes here and here, has to be split up equally, so everyone gets an x squared. Factors of 1 are just 1. Then you're going to break up negative 2 goes here and here. I'm just trying, what gets negative 2? How about negative 2 plus 1? I'm going to see if I'm right by multiplying this. This would be negative 2x squared, and this would be plus 1x squared. That adds together to negative 1x squared, which is what this middle term is, so that looks good. I will tell you these other two, this is not factorable over nice numbers, nor is this one. So this is our answer for fully factored. I want us to look at some more examples, so let's look at number 2 and number 3 here. Notice number 2, there's 4 x's here, there's none here, you can't pull anything out. There's no number you can pull out, so all you can do is break it into 2 groups. There's no middle term, so the middle term is 0. All I can do is equally break up x to the 4th. That means x squared and x squared. When I multiply this and this, I'm going to get 0. So how do you find factors of negative 16? Well, it's 8 and 2, 16 and 1, 4 and 4. I'm going to try plus 4 minus 4. This would give us a 4x and a minus 4x, which is no middle term. Now this one cannot be factored further, but the second one can. So I'm going to rewrite this first one down. And I'm going to further factor this last one. X squared be broken into x and x. A negative 4 is either 4 times negative 1 or negative 2 times 2. Adds to a 0 middle term. So if you do plus 2 minus 2, you'll get 2x minus 2x, which is 0x, and that works. So this is the final answer. Now if we look at this example number 3 here, again you want to look and see if there's any common numbers or common number of x's you can pull out of all 3 terms. If you look at it here, we have 5 x's here, there's 3 here, and there's 1 here. So at the most we can pull out 1, so we're going to take that one out of all of them. So I'll keep the x. There is a common factor of 2, 4, and 6, which is 2. So I'm going to yank a 2 out. So to simplify, 2 divided by 2 is 1. Pulling out 1x leaves me with 4. Negative 4 divided by 2 is negative 2. Pull out 1x leaves me with 2. Negative 6 divided by 2 is negative 3, and that 1x is gone. Now I'm going to keep the 2x here, but I'm going to think about how I can break down this x to the 4th. This can go into 2 groups. And again, I'm going to keep the 2x there. All you have to do is the x to the 4th has to be equally broken up between these first 2. And again, the negative 3, multiples of negative 3 will go here and here, such that when you multiply these 2 and these 2, it will add to negative 2x squared. Now don't worry that it's a 2x squared, it'll just naturally happen, because here's what happens. The only way to equally break up x to the 4th, which is this, is to give each a group of 2, so it has to be x squared and x squared. And there's really only one set of multiples to do negative 3. It's either negative 3 and 1 or negative 1 and 3. They have to add together to be negative 2. If you look at these 2 combinations, either this one or this first one will add to negative 2. So try negative 2 or negative 3 plus 1. If you check it out, this multiplies here to negative 3x squared. X squared times 1 is plus 1x squared. And those add to negative 2x squared, which is this right here. Now this one cannot be factored any further. You might want to try, I could see checking to see if this one could be factored further, but you're going to find out it doesn't. So my final answer will be here. This is a really nice one for practice. Again, you want to look and see if they all have a common number and a common amount of x's to take out. There are 6 x's here, 4 here, and 2 here. So at the most you can pull out 2. So I'm going to do x squared. Is there a common multiple for 8, 32, and 24? The highest one you can pull out is actually an 8. So I'm going to pull the 8 out also. So let's simplify. 8 divided by 8 is 1. Pull out 2 x's, it's x to the 4th. Negative 32 divided by 8 is negative 4. Pull out 2 x's, x squared. Plus 28 divided by 8 is a 3, and those x squareds are gone. This is going to be similar. I'm going to keep the 8x squared. I'm going to factor out these two. X to the fourth equally gets broken up here and here, so it's x squared and x squared. I need to think of, are there multiples of positive 3 that I can put here and here, such that when I multiply that and that, it'll actually add to a negative 4x squared. There's two options to try, either 3 times 1 or negative 3 times negative 1 will work. They have to add to negative 4, so it's going to have to be the negative 3, negative 1. If you check here, negative 3x squared, and this is negative 1x squared, which will add to negative 4x squared. Now, one of these terms can actually be broken down further, and it's this last one. This can be factored more. So our final answer, the 8x squared, is there. The x squared minus 3 won't be able to be factored down. The x squared minus 1 can be broken into two groups. I'm going to break the x squared down into x and x. I need factors that multiply to negative 1. It's plus 1 minus 1. Such that you notice there is no middle term in here. It's a 0x. So does it work? 1x, negative 1x adds to 0. So this actually is the final answer in fully factored format.